Class, this is Dr. Selby here, and today I want to talk about isotope symbols. Before I do so, I'd like to give a little bit of background stuff. This should be review that things we know, but I want to bring this information to the forefront of your minds. And that is, what are the subatomic particles? So what does every atom have? So every atom has protons, and they're located in the nucleus. Here's the nucleus here. And their mass to two significant figures is 1.0 AMU, and their charge, as indicated here, is +1. We also have neutrons inside the nucleus, and they also have a mass to two significant figures of 1.0 AMU, and they're neutral, so their charge is 0. Finally, we have electrons. Electrons are outside of the nucleus, and here I have it drawn outside of the nucleus. However, this is not to scale. If you're at home looking at this on your computer or your phone, that electron is, a couple blocks away. So this is not to scale. So they're outside the nucleus, very far away from the nucleus, and their mass is negligible. If we needed to express the mass of an electron in unit AMU to the 10th place, it would just be 0.0. Of course, way far down the line, we have some actual digits. But so we just know the mass of electrons are negligible. That's the point. And they have a -1 charge. Okay, some other things that we should know are, 1, atoms are neutral. The number of protons equals the number of electrons in a neutral atom. There's these things called ions. They are not neutral. And in an ion, it has a charge, and the number of protons is not equal to the number of electrons. Another thing we should know is that the identity, the elemental identity of an atom or ion is always determined by the number of protons. So charged or not, an element will always have the same number of protons. An example is hydrogen always has 1 proton. Lithium always has 3 protons, and so on. So the identity is given by the number of protons. To make an ion, what happens is an atom will gain or lose electrons. So to create an ion, electrons are gained or lost. The total charge on an atom and an ion can be calculated by summing all the total charges in that particle. What do I mean by that? So here I'm depicting hydrogen that has always 1 proton. It's an atom, so it has 1 electron. And we add those charges, we see that the charge on that atom is neutral. So we have a +1 and then plus a -1, and that equals 0, indicating that it's an atom. Okay, next. Atoms and ions of the same element can have different number of neutrons, and these are called isotopes. Next is the number of protons of an element, this should say of, sorry, an element is given on the periodic table. And then the number of neutrons of a certain isotope of an element is not given on the periodic table. Okay, so what is an isotope symbol? Isotopic symbols. An isotopic symbol will always show think of a big square box. It will have the chemical symbol of that element. In this case, that chemical symbol is H. And then in the top left-hand corner, it's going to have the mass number. And in this, the mass number is the number of protons plus the number of neutrons. So here we have 1 neutron plus 1 proton. So it's 2 in this case. And then not always shown in the lower left corner here is the number of protons, which is also called the atomic number. Okay, so in this case, we only have 1 proton. That's there. And then if there's something here, then you have an ion and not an atom. If it's an atom, you don't show charge because it's just 0, but if it's an ion, you would show charge up in that corner. So here's a recap is top left corner, we have the mass number, which is number of protons plus neutrons. Bottom left corner, we have the atomic number, which is equal to the number of protons. The big symbol in the middle is the chemical symbol of the element. And then in the top right corner, if it's charged or if it's an ion, we would indicate it right here. Okay. This is just a piece of a block on the periodic table. And we have, for hydrogen, it's showing the atomic number 1. The atomic number, again, is equal to the number of protons. We have the chemical symbol, and then we have the spelling of the name. Atomic mass is not related to isotopic symbols. As you have read or might have read in your textbook, atomic mass is a weighted average of all isotopes, and I'm not going to cover this topic in this video. Okay, let's, what is the needed information to determine the number of subatomic particles if you're given an isotope symbol? And all you need is a periodic table and that background information. This periodic table I'm going to use is taken from the Atoms First 2E free textbook from OpenStax. And instead of showing the entire periodic table, what I'm going to use are blow-ups of individual elements as needed. Okay, so let's go through examples. Learning by example is always the best way to learn. So I want to fill in this table below given this isotope symbol. And let's see, what do I know first? Well, this one here, this 6 here, what is that? That is the number of protons. It's also the atomic number. So that is 6 here and 6 here. If you're looking at a periodic table, on the OpenStax periodic table, in all periodic tables, it lists the atomic number. So that's the atomic number, and that's equal to the number of protons. Notice that we do not have a charge here. There's no charge indicated. That means that we have a neutral atom. So if you have a neutral atom, that means the number of protons equals the number of electrons. So the number of electrons is also 6. Okay, now what does this 14 mean? This 14 here, that means that is the number of protons plus the number of neutrons equals 14. Well, we already know that the number of protons is 6. And so the number of neutrons has to be 8. So we did a little math there. So we had to calculate it. Another way to say is that your mass number, often indicated by A, so A is the mass number, equals number P plus number N. And then if you're trying to calculate the number of neutrons, then you just take mass number minus number of protons equals your number of neutrons. Or in this case, you would say 14 minus 6 equals 8. Okay, so you have to do a calculation. So let's just show that calculation here. This is 14 minus 6 equals 8. And that's our number of neutrons. And then our mass number here, that's what was given. So our mass number is that 14. Let's look at another example. It says fill in the table below for this isotope symbol. And notice it has a charge. It has a -2 charge. So this is an ion. It's a negative ion. So this is an anion. Okay, what never changes? This is the symbol for oxygen. O we see on a periodic table. O is oxygen. And oxygen, the number of protons is always given by its atomic number. So that's on the periodic table. So that's 8. The atomic number is 8. What about number of electrons? Oh, this thing is charged. So how do we find this? So we sum up the charges. We know that the total charge from the protons, so that will equal the number of protons, that's going to be positive, and then plus the number of electrons. And the reason that's negative there is because electrons are negative. So we could just write this as number of protons minus number of electrons equals the total charge. Okay, so now we have to solve for the number of electrons. So number of electrons equals the number of protons minus the charge. Okay, so what is our charge? Our charge is -2. So we have -2. And our number of protons is 8. So our number of electrons equals 10. It's probably easier to do it in your head, honestly. We have a charge of -2, and we have 8 protons, so it must mean we have 2 more electrons than protons. That is way easier. So we have 10 electrons. Number of neutrons. Number of neutrons is not in the periodic table. We have to calculate it. And so we take the mass number, which is the number of protons plus the number of neutrons, and subtract off the number of protons. That gives us the number of neutrons. So we have 17 minus 8, and that equals 9. So this is 9 here. And the mass number, well, that was given right here, and that's 17. Next example. We have copper here. We have a +2 charge. Copper, looking at the periodic table, has atomic number 29, and that's equal to the number of protons. Number of electrons. Well, this whole thing has a +2 charge, which means that it has 2 more protons than electrons, or 2 less electrons than protons. So in this case, we have 29 protons. We must have 27 electrons. I think doing it in your head without some equation is way easier. Number of neutrons. Well, we're given the mass number 65. I can fill that in here right now. And so we take 65, which is the sum of protons plus neutrons, and subtract off the number of protons, which is 29. And that gives us 36 neutrons. That is the end of this short micro lesson. If you have any questions, send me an email. Thanks and have a great day.